Afternoon, all. There's going to be a little bit of duplication between this and the previous presentation in the middle, but it'll only add to the 9-10 activity, hopefully. This is a presentation that we came to a decision on the title quite a few months ago, and it finally came to fruition. Right, that way round. Can't do it left-handed. What we're going to cover: why we need to monitor and control amplifiers, some methods of doing the measurements, and then we're going to look at three case examples. It's a very picture-orientated presentation. No circuit diagrams and definitely no mathematics as per the microwave update criteria. Some conclusions, and then I've taken Michael's example and I've put one of the bullet points as XXX, which we'll come to right at the end of the presentation after the questions. The need. Why are we going to get involved with all this circuitry that we're going to discuss here? When you're running a small dish, like my 3-meter C-band dish, every extra 0.1 dB loss on transmit hurts. It doesn't hurt you so much on receive because you can put the preamp right on the feed, as we've just seen in the previous presentation. But every 0.1 dB loss on transmit hurts. And as Gerald, K5GW, once said on one of the Tuesday lunch times, there is no place for superflex on an EMI dish. So you conserve what power you've generated by putting the amplifier right out at the dish. But the problem with putting it out at the dish is out of sight, out of mind or something. You don't know whether it's still working unless you've got echoes and you can see the echoes and they suddenly stop and you think, oh, the amplifier's died. Not very scientific, but it has been used. So you need some method of monitoring the amp, what the amp is doing. And also it would be nice if you had a bit of intelligence so it could protect itself while you're being distracted. You know, where you're reprogramming the keyer and the amplifier's just gone offline and you don't really know about it. So the four criteria that I'm going to look at in this presentation is to monitor the temperature, the current, the voltage, and the output from the amplifier, the RF output. The remote PA. This was a March Texas afternoon, and this is my VK window. Actually, it's the start of my VK window. It finishes with me actually pointing through the wooden fence. But what you can see here is a dog kennel, or as the label on it when we bought it at the flea market in Dallas said, a dog loo. There's a whole series. There's a cat loo, a rabbit loo, a whole series of these devices. But as it only costs $10 and it survived 7 years, even the plastic in the Texas sun, it was a good investment. And this here is also Texas. Yes. This is what happened when you try to do the Dubas 9 centimeter contest in 2010, which was like April time, I think. The first day, it was like this. On the Saturday, on the Sunday, I woke up to find this. And you can see the dog kennel is with the amplifiers under there. So with the amplifiers out there, the shack, I should point out, is about there in the garage. You need some way of looking at it. Measuring methods. There's lot more detail in the presentation. And on the DVD, there's also some data sheets on these devices. So I'm not going to go too seriously into the workings of these devices. The national measures temperature. Yes, there are chips that can measure temperature with SPI or I2C buses, but I just wanted an analog voltage that I could do an A to D on in the controller. The LM34 is a 3-terminal device. Just looks like a 78LO5 type device. And it outputs 10 millivolts per degree F. There is an for the European market. There is an LM35 that does I think it's 10 millivolts per degree C. But it has a lower resolution, so I went for the F version. The current is measured with an ACS 713, which, much to my surprise, you can put. It's a SOIC 8-pin IC. It's a surface mount 8-pin IC, and 2 pins are the input current, 2 are the output. So you've got these 2 little SOIC pins, and they're sticking 20 amps, and there's actually a 30 amp version that has the same configuration. I couldn't believe this would survive, so I tried it, but it does. They do a 50 amp version and a 75 amp version that Paul Wade wrote up in his lossless current meter many years ago. But that looks like a TO220 device with 2 lobster claws sticking out the end, which carry the main current, and then there's the 3 normal pins that you actually do the monitoring on. RF, a lot of the amplifiers have got onboard diode detectors. You just take the DC output from them and use that. And of course, you have to have a controller and flavor of the month. And in fact, I dug out my original PIC Kia program from the East Coast conference back in the mid-80s when I first started these. I've stuck with them. They've served me well. So, the W6PQL amplifiers, this is the first case example we're going to use. I've got a TH338. I've used it. It took over from my EMI Electronics 2x2C39 for EMI. And I wanted to replace it because it was big, bulky. And I saw that W6PQL was doing a board with 2 times MRF 286s. And he was claiming 170 watts. Well, I searched for devices. I thought it was a good idea, but search for devices was going to be, it took a long time. Then I saw an eBay listing, and I bid on it and didn't get them. But then I got an email, because it was one of our locals, K9MK, who said, yes, I've still got some. Let's speak. And these were actually genuine, out of the Motorola test labs devices. They didn't come from some far western country, which I know people have had some issues with whether they really behave like MRF 286. In fact, the ones I've got currently are labelled XRF 286s, which mean they were the lab devices. So I've got 2 boards, an input and output combiner, and a big heatsink. Here's the circuit. 2 devices, splitter on the input, splitter on the output, and there's an output detector. Although for some strange reason the output is negative voltage. Don't connect that up to your PIC. It doesn't like it. The negative voltage on the 8 of the input fries it. Been there, done that. And here was the initial configuration. 2 pallets with 2 devices, the PQL input combiner and the output combiner, and 20 watts in produced 350 watts output of 28 volts. You can see the 28 volt rail is connected together, and so is the bias, because they've got individual bias pots for each device, which allows you to equalize them. So what do we need to keep this device healthy? Fan control. And as I said in the paper, there's two forms of fan control. The one is the, I'm getting hot, I better put the fan on type control. And the other one is, oh, ow, oh, ouch, I'm very, very hot. You ought not to be transmitting until I cool off. And the temperature sense that we've had takes care of both. SWR protection, if the amplifier falls off, it goes into pass-through mode. You need to monitor the output of each module to make sure they're still balanced and one's not producing all the power and the other one's producing a little bit of power. Overcurrent protection, that is mainly protection against overdriving it. Because as 2 people have already said today, too much drive plus too much bias is end of device, as I proved on the i0JXX design, which we'll come into later. So here is the controller. We're not going through detail. The PIC's in the middle. There's an LCD, standard. It's not a GL graphics one, it's just a standard one. Here is the 8-pin current sensor, the 3-pin temperature controller, and then there's various outputs for switching relays. And I like the FET switches, because unlike the the transistors, you can sink like 30 amps through these devices. They're never going to blow. And they're logic compatible. Regulator that provides a 5-volt rail, which is the reference for the A to D converters. And there's some inputs. There's a push-torque input, because it also switches the bias. There's an alarm reset, and there's also an input that you can term the preamp, because this output also controls the preamp volts and the protection regulator that we just saw. Here's the finished amplifier. The 4 boards we've seen before, the input combiner, the output combiner. There's a big 28-volt relay there that switches the whole volts on. Down here, we've got the PIC board. Down here on this edge, we've got the display. Here is a directional coupler. It was out of a cell site. It did forward and reverse. And the spec on it is a kilowatt. Why they had kilowatt directional couplers in cell sites, I'm not quite sure, but it works fine. You can see the 2 phonos for forward and reverse coming out of it. And you'll see here is a piece of FSJ1. When this thing is producing 400 watts, and you put a piece of the semi-rigid here, which is okay at 200 watts, which each module is producing, I put semi-rigid here into the coupler, and I actually burnt myself after key down. So we went to FSJ1 and protected our fingers. So with all this extra protection, because I can I can trip on over current, over voltage, excess reverse power, 20 watts now gives 400 watts output. And this was in the shack. And here is the front panel display in the shack. You can see the voltage. You can see the current for one module, the current module for the other module. You can see the output from both sides. Yes, the math doesn't add up. It's within quantizing error. And you can see the forward power is 400 watts, the reverse power is 15, which is about par for my feed. So we got that working in the shack, so then we had to put it out at the dish. The main difference is there's no LCD display, but there is a line driver. Now, initially I tried... Oh, that's wrong. Initially I tried RS-232. And the distance from my EMI shack in the garage and the dish is about 60 foot. Well, it was very flaky, the RS-232. You'd miss bits, and it'd say you're on transmit, and you weren't. So we got rid of that. And I was looking at W2DRZ's remote sensors for his dish tracking. And K1RQG pointed out that he was using RS-422, which is the balanced version of RS-232. So I got the Max 481, which is the driver chip, and now I can run... I did try 250 foot of cable, and it still worked. So that's what we use. Contrary to what it says here, that should say 422. And the remote display is just a PIC, a level converter, another Max 481, and an LCD. And surprise, surprise, in the shack it shows exactly the same values. But you can see this is the little box. I've actually got a series of 3 of these, and I can just change the PIC and go between the different bands. There's one PIC for 9, one for 23, and one for 13. Okay, the Toshiba amplifier, which you've just seen a little on. Oh, I should point out, the W6PQL, I did notice before I came over on the plane that PQL is now selling the PCBs again for this. He stopped producing them a couple of years back, but he's now producing them again. That was the thing. I knew there was something else I was putting there. The Toshiba amplifier. Originally, I used a single QRO Toshiba amplifier. But I decided I need 2 amplifiers. Well, actually, I used a single one. Then I decided to put the single one on the dish feed. And we had a lightning strike 40 foot away from the dish, and that was the end of this $350 amplifier. So at that point, we decided that it was not going suspended in mid-air on the dish anymore. So we decided we needed to go, we could just see echo some of the time with this 45 watts. So we decided we need to combine 2 amplifiers. You can actually run 11 volts. They're internally regulated to like 10.5 volts inside the Toshibas. But you need about 35 amps at 12.0 volts to power it. So I combined the RF parts for 2 and got 10 milliwatts in, gives 100 watts out at 3400. And as you can see here, you can actually see I could get echoes, which meant I could keep the dish on track, which was a great advantage. It's always helped with a small dish. When you've got echoes, you can keep well tracked. Here's the amplifier. And yes, I have got these swept connectors on these, although the observer may notice that one is pointing in the opposite direction. So I had to take it apart and take all the screws out to turn one round so I could equalize the cable. This is a NADA coupler, which is rated at 200 watts. There's a smaller coupler on the input. I should say a hybrid splitter. It's got the 0 to 90 degree phase, like John said. And here you can see there's one of the 8-pin SOIC chips on a board for that amplifier. There's another one over here for this amplifier. Here's the PIC on its board. There's, on this one, because it's only going to be remoted, I'm not going to use this in the shack and throw all my signal away. There's two, the LED bar graphs, so I can actually see something's happening out at the dish when I've got the display inside the shack. And you'll notice there's 2 power connectors, because initially I had to run a 13.8 volt 20 amp power supply on each amplifier. But luckily there were some 12 volt 55 amp HP server power supplies that came onto the market in the US for like $35. So now I can run it off just one power supply. But it saves the volts drop on this on these power leads coming out to the amplifier. So that's the Toshiba. Same needs. This is only remote. There is no front panel display from the Toshiba, partially because it's so thin that you couldn't actually get a display on the side. You need the fan control, reverse power output protection, overcurrent protection, and bias control. The PA is at least 50 foot from the shack, so we use RS422 for transfer of the data display. Now, Charlie, you were talking about amplifiers earlier, fans a little earlier. This is the Texas configuration. You can see here the very thin thing with the 4 fans on the top is actually the amplifier. Buried under it are the 2 power supplies. The transverter is at the bottom. The 10 megahertz GPS reference comes in here. But this was in July, and it was a bit hot. It was 106F ambient. And the amplifier kept protecting itself and turning it off at most inopportune moments, i.e. just after I started transmitting. So I stole Meg's fan out of her stained glass room and sort of put it at the right angle to blow more air over it. And yes, you will notice it's got UK mains plugs, because that's how I keep the 110 volt and the 240 volt separated in Texas. There's a 110 feed for the power meter and a 240 for the amplifier and the big power supply. And you can see the base of the dish here, how close it is. This is remember me saying, Gerald said there's no room for flex on the dish? He didn't say anything about on the floor by the dish. So there's actually a small flex here to allow for the dish to move and not pull the connectors off. And then there's a piece of LDF4 that goes to the feed point. Normally there's a directional coupler, a forward and reverse coupler that sits here, which plugs into the amplifier, and the forward and reverse power goes to the shack. The amp remote unit, you may notice, is very similar to the 1296 one, except that this one's got 2 current monitors, and there's an RF. We were told earlier that there's an RF output from the Toshiba, so you use that for the forward power on both to make sure they're behaving themselves. And the RF forward and RF reverse are for the external couplers. Here's the cable. I couldn't decide what sort of cable to use to go between the amplifier and the shack. And I found out that Tanner's had got some 6-pin mini DIN keyboard extension cables in 50-foot and 100-foot lengths for $10. So that's why these are 6-pin mini DINs, like you have on the keyboard on your PC. And they're molded so they are waterproof for odd occasions when we do get rain in Texas. And it says here, no communication over 422 link, RS232 doesn't work at 70 foot. Here's the local display. Again, a PIC, LCD, and the input data. And it has to have a few LEDs because you won't be able to see from the other side of the shack that something's going right without having to peer at the LCD and try and read it. So it does have an alarm, an activity, and a transmit LED. It's a little dark. Can't see it from over here, but you can see it a little better here. These are in the proceedings, but in the normal run of things, it shows, like we did on the 1296 amplifier, volts and amps for amplifier A, volts and amps for amplifier B, forward power, reverse power, the temperature of the chassis. There's actually an LM34 right in the middle of the chassis, so it gets the whole temperature from it. And then the LEDs that show you where you're going. And over here, this is, for those who can't read it, it says volt error, because it's current error, which is an overcurrent. Current error, attend to issue. And it sits there, and you have to go out to the dish and take care of it. Because I found that if I did this, if I had a reset button in the shack, I would oh yeah, ignore that, just press it, and then you go on, and then you lose the amplifier, which is another amplifier. Luckily, it was only one of the 20-watt versions, that one. But yes, it forces you to go and actually investigate the problem rather than, yeah, that's just a glitch, I'll ignore that for the time being. Very dangerous with these amplifiers. Okay, then we all went to Florence, and I bought one of the i0JXX amplifier modules. And I decided, after all these years and years and years and years and years, I ought to get back into 2-meter EMI. So, again, it basically needs the same things. But 2 meters, you lose 0.1 dB or in the heliax or whatever out to the Yagi. You don't need to remote this. So this is just a local only. You're at the amplifier, you can see the amplifier. So you just need an LCD. You don't need to have RS422 cables going out there. So you need status display, fan control, SWR protection. You need to measure the output. You also need to make sure the overcurrent protection is there. That was where I hit the reset button and overdrove it again, and that was the end of the device. And the replacement device for that was $250 from Mauser for that amplifier, the single device. Once bitten, twice shy. I made sure that there's no way you could override the overcurrent. It was serious when that happened. It also does the bias control, because the i0JXX, you have to put minus 5 volts on it on receive to turn off the device. And as I said, there's no need for a remote display, because it's going to be in the shack. So here's the amplifier. Very similar to what we've seen before. Temperature sensor, current sensor. Yes, I included the pinout on the diagram because I could never find the data sheet when I went to wire it up. So this is like a crib sheet. And down here you'll see the quite complicated 48 volts in. Now, LM317s, which is the adjustable regulator, the maximum voltage input to that is 37 volts. Exceed at your peril, they will smoke. And when you see a little hole in the top, that means it's escaped. But I found out from Steve Costro of Down East Microwave, who was building some 48-volt 6-meter amplifier that did 350 watts. It's got a cousin called the TL783. Same package, but you can stick 140 volts in on this one. At least 120. I've only tried it to 120. And people using it for regulated tube amplifiers to regulate the anode supply. It'll take, I think it's about an amp you can put into this. So we take the 48 volts, we put it into the TL783 because that's okay, that's well below its 120 limit. And then we produce 12 volts, which drives various other things. And we drive the LT1054, which generates the negative rail. And then I've got some FETs, which actually switch the bias to -5 on receive and not on transmit. And some may notice the similarities between this and the power supply regulator bias board that I did for the Qualcomm amplifiers maybe 15 years ago. The only change is the 783 on the input. Again, there's sequencing preamps, preamp protection relay, masthead preamp, and the PA actually changeover relay. So this is what it looks like. Here's the amplifier module. This very pretty blue coax on the output. Here's a fixed 6 dB attenuator, because remember, we don't want to overdrive this. We've already lost one device. We're not going to do it again. This is a 6 dB pad, so it means my Elecraft K3 can never overdrive it. The input relay into the amplifier and the output relay. Again, I found a surplus directional coupler, a directional detector, because it actually gives a DC voltage output on the output. And here is a low-pass filter using those big door knob capacitors. I was struggling for a design, but WA1ZMS, who was doing the transatlantic beacon, had come up with this design, and I copied it, and it works fine. You can put 500 watts through it, key down, and it's quite happy for quite some time. The pick is down here. This resistor is the backlight dropping resistor for the LCD display. It used to get hot, so I hung it in midair. This is the regulator board that does the switching. Here's the PIC controller. So quite a compact unit, and we can actually see it in use here. Yes, on 2 meters, I don't have to worry about the cable. I don't have to go and sit out in the garage in the 106 degrees and play radio. I can actually sit in the shack on the kitchen table and play radio. And you can see the LCD displays on the front. There's a big fan on the top. Yes, the Z3801 GPS locked reference for the 10 meg reference for the K3. And the power supply, oh no, that's a dummy load. The power supply is this thing here, because it takes 48 volts, but I've got a couple of 33 amp power supplies over there, which power it quite well. So there's 3 examples. I say there's lots more data on it, and big circuit diagrams and data sheets for the devices in the proceedings. I did actually see that ACS 713. It was actually cheaper to buy coming out of China. Assuming the chips are okay. There were some pre-mounted boards which got like 2 screw terminals for the input and output current, and they were actually cheaper than buying the devices from ACS. So here is some links to the sites for the amplifier. PQL, as I say, he now has boards. And I noticed the other day that he's now doing kilowatt solid state on 432 and a kilowatt solid state now on 220. He's really taken off in the amplifier side. The i0GX6 amp is on the website. Although this 500-watt amplifier will probably get upgraded before I bring it back. I've got one of the F1JRD kilowatt modules that's up and running. I just need to rescale and redo the code to protect it. The single Toshiba amplifier is there. And also on that website is a transcription, that's probably the best way, a transcription of the original data sheet for the specs for those devices. Because they were originally designed for 3.4 gigahertz fixed wireless applications down in South America by AT&T, which is why Pyro Joe in Florida got a lot of them. He said that initially the initial batch was 750 of them, and as you've heard, just they're all gone now. But people have still got them squirreled away for a rainy day, but they're not in use. And there's the link. That is the generic link. All what we've just seen, and some other protection circuitry and switching for my EMI operations is at that location. Later on in this year, I'm coming back to the UK. I always promised Meg I would, and we are indeed coming back. So I thought it's been an interesting exercise as the final slide to actually do the summary of what I'd worked in Dallas. The first QSO was Howard, G4CCH, in 12th of December 2005. The first time I listened on the band, he was talking to V6TA about my imminent appearance. but I worked Howard first and then V68 second. And my last QSO was Gerald, and I made him work hard. I made him work really hard for this 5.7 QSO. He complained at the NTMS lunch the following Tuesday. For the first time in his 30-year EMI career, he had to send a T report. I was so confused, Al had to explain to me that evening what it was all about, because I'd never heard it before. But the funny thing was, later on that weekend, he had to send the T report again when he was trying to work V6 TA. It's like, well, Gerald, if 5.7 was easy, we'd have done it years ago. So the last QSO was Gerald on that, and here's the stats. I had EMI QSOs on 7 bands. The 2 on CW on 144. I had a period with the 4 FO Yagis on 432. 32 Qs, 14 countries. This was a challenge. It's one of these, it's there, I have to do it. And so there was 1 QSO with Al on 902. And believe me, that is not easy when the other station's only 8 kilometres away. You have to do it at moonrise. And you have to be very careful on your timing to separate the direct and the EMI. It takes more practice than you think. 1296, which was the major band, total of 372 Qs, exactly 100 grids, and 39 countries, 13 SEMs, 130 Qs, 54 initials, and exactly 50 grids. The last one was W09FWD, who gave me number 50. 3400, as somebody said earlier, it's a really good EMI band. I really liked it. Once we all got on 3400, and we didn't have to all have 2 transverters, and some people were on 3456, and some were on 3400. Once we all got on 3400, it was much, much better band to be on. 23 grids, which when I counted them, I was really surprised on, and 15 countries. Considering it's not a worldwide allocation, I was surprised by that. And then the thing that was holding me up was a QSO on 5.7. I tried for 4 years for those QSOs. I almost worked F2TU at one point, but the R in my call and the R report confused him, so we didn't complete. So I had to wait another 3 years before I got to work at AL, and we struggled, but we got there. So Gerald's 5.6 centimetre QSO was actually QSO 601 for WW2R, and that will indeed be the last one. But the good news is that hopefully we'll be appearing from Wales next. There's a possibility of a station in GW, especially on some of these higher bands. The other good news is that the dish is not going to be chopped up. I got it as one of our locals was leaving to go move house and go south down towards Houston. So I got it for, if you pick it up, you can have it. But the dish is going to WA5 TKU. It would have it by now, but we had some transport difficulties. So he's going to have it, and he will be on, initially on 23. We're going to take it around there, get it set up. He's going to borrow my feed, and we're going to try and make sure the dish works before I leave the country. So all is not lost. The dish will continue. And yes, he's getting it for the same price as I did. Come and pick it up. Thank you.